the movie. So the hypothesis is that we consider a temporal increase in nominal money stock. So an increase of the nominal money stock from M0 to M0 plus epsilon between T0 and T1. Then the nominal money stock is again equal to M0. Okay? So this is a temporal increase. How we can again derive the dynamics of the exchange rate between T0 and T1? Because the problem is between T0 and T1. Try to write the initial equation in which you derive the exchange rate dynamics, and then I will show you the correct one. Okay. So in this case, the exchange rate, I write again the general form, should be equal to 1 over alpha 2 integral between T and T1, between T and T1. Again, this is the most problematic issue, T, because you need a function of T. This dynamics should be true for each T between T0 and T1. This is the reason why we put T on the integral. So, until T1, the nominal money stock is M0 plus epsilon. And we need to discount this nominal money stock, which is the only fundamentals, okay? And this is the first part. Then you have a second part also. Because after T1, the nominal money stock is equal to M0. Again, you have the exit strategy. So you have plus the integral between 1 over alpha 2, the integral between T1 and plus infinite of M0, which multiplies the discount factor, which is the same. And you have to solve these two integrals. Okay. Our delete. Yes. Okay, we know that, I write again, the exchange rate is equal to 1 over alpha 2 integral between T and T1 M0 plus epsilon e to the power minus v minus T over alpha 2 in the v plus 1 over alpha 2 integral between T1 and plus infinite M0 discounted at time T over alpha 2 in the v. Okay, we know the value of this integral. We can put outside the integral many things. We have M0 plus epsilon over alpha 2 and also e to the power of T over alpha 2 in this integral. And you have again the integral between T and T1 of e to the power of minus v over alpha 2 in the v. And it's the first part. In the second part again you have outside the integral M0 over alpha 2 e to the power of T over alpha 2 integral between T1 and plus infinite e to the power of minus v over alpha 2 in the v. So St equal to M0 plus epsilon over alpha 2 e to the power of t over alpha 2. The value of this integral is minus alpha 2 e to the power of minus v over alpha 2 between t and t1. The second part is plus m0 over alpha 2 e to the power of t over alpha 2, and the integral is the same, is minus alpha 2 e to the power of minus v over alpha 2, but now between t1 and plus infinite. We can simplify something, alpha 2, alpha 2, alpha 2, alpha 2, and alpha 2. And we need to compute the integral between t and t1, and the second between t1 and plus infinite. So this is just the derivative. So we get st equal to m0 plus epsilon, which multiplies e to the power of t over alpha 2. What is the value of this integral in t1? Is minus e to the power of minus t1 over alpha 2 minus the value of this function, which is minus e to the power of minus t over alpha 2, because we need to compute the value in t. The value in t1 minus the value in t. The value in t1 is this. The value in t is this. It's better to change. Okay, so the first part is st equal to m0 plus epsilon e to the power of t over alpha 2 minus e to the power of t1 minus t1 over alpha 2 plus, because minus minus it becomes plus, e to the power of minus t over alpha 2. The second part is plus m0 e to the power of t over alpha 2, which multiplies. Okay, the value of e to the power of minus v over alpha 2 as v goes to plus infinite becomes 0. So the first part is 0 minus the value in t1 is equal to minus minus plus, or I can write here minus minus e to the power of minus t1 over alpha 2. So we get st equal to m0 plus epsilon, which multiplies, if we multiply this by these two components, we have minus e to the power of t minus t1 over alpha 2, which is the first part, multiplying this by this, okay? Plus what? Plus e to the power of 0, which is 1. And the second part is plus m0 e to the power of, this is plus, minus minus becomes plus, e to the power of t minus t1 over alpha 2. Try to check this computation. So multiplying, you get this result. Can you check that this result is correct? Is it correct? For me it's correct, but I am not sure. Just to multiply so the final result is St equal to m0. Then we can collect epsilon between this and this, and you get epsilon, which multiplies 1 minus e to the power of t minus t1 divided by alpha 2. This is the dynamics of the exchange rate between t0 and t1. Stop removing. If t is equal to t0, what you get? You get St equal to m0, because the second part is equal to 0. But we know that the exchange rate after t1, starting from t1, will be equal to m0, because the nominal money stock is equal to m0. The problem is to draw this function, show you this dynamics, because now you have a minus inside the square brackets. You have minus c, so this is a decreasing function in time. It's not an increasing function, it's a decreasing function in time. The dynamics is the following. Yes? Oh, Yoshi, yeah. Sorry. The dynamics is okay. We have t0, we have t1. Okay. Before t0, the exchange rate is m0, because the expectation is a permanent stock equal to m0. After t1, we know the exchange rate will be again equal to m0, because the nominal money stock is again equal to m0 forever. Okay. What is the value of the exchange rate in t0? In t0 we need to substitute in the equation t equal to t0, and we get a jump lower than epsilon, because I write the equation. The question is St equal to m0 plus epsilon, which multiplies 1 minus c to the power of t minus t1 over alpha 2. This is the dynamics, okay? If you put t0 in t initially, the jump is lower than epsilon, because epsilon multiplies 1 minus a number lower than 1, okay? So you have this jump, which is not m0 plus epsilon, is lower, okay? You have this jump, this depreciation. But now the dynamics is this. Is a continuous appreciation in the exchange rate. Is a decreasing function in time. Now we need to understand why. So the depreciation in T0 is lower than the increase in nominal money stock, which implies that the real money stock increases. But if the real money stock increases, in the money market, the interest rate reduces in order to restore the equilibrium. But the interest rate reduces if the exchange rate appreciates, given the uncovered interest parity. I try to repeat these dynamics. In T0, you have an increase in nominal money stock equal to epsilon, which is temporary, but in T0 the nominal money stock increases by epsilon. The exchange rate depreciates by a lower rate, by a lower percentage, lower than epsilon. This implies that the real money stock increases, which is the difference between the two. If the real money stock increases, in the money market, the interest rate should reduce. In order to reduce the interest rate, the exchange, given the uncovered interest parity, the exchange rate should appreciate, should reduce. And this implies a further increase in real money stock. And again, a reduction in interest rate and a further appreciation. This dynamics, this continuous appreciation. In T1, you have a sudden, not a sudden, an expected reduction, an actual reduction in the nominal money stock, which becomes lower than money demand. In order to restore the equilibrium, the interest rate should increase, should jump upward to the level of the falling interest rate.